then what are the four primary tissues?
Muscle, nervous.
Okay, I hear you guys. Oh, I think. So muscles, nervous, connective, and epithelial. Okay. Next page. Okay. Next page on eye. What are the three different types of muscle tissue? This is all review from 100. Two. Which type of muscles have the slowest frequency? Okay. And then the fastest? Very good. J. Nervous tissue consists of cells specialized. Name three ions that are involved in transmitting electrical impulses.
Sodium, potassium, calcium.
Very good. Sodium, potassium, and calcium. Are we going too fast? Huh? Oh, okay. Just type. Oh, okay. We'll wait. The slowest is smooth muscles, and then the fastest skeletal, and then intermediate would be cardiac. Are you catching up?
Yeah, I just needed like 3 more seconds.
No, it's okay. All right, we'll wait. Anybody else here, or are we a little fast? Just let us know. John, you're ready? You good? Okay. Okay. K. We're on K. 1. What is a gland? That would be it's made of epithelial cells. And 2. And there's 2 types of glands. What are they? And differentiate between their functions. Endocrine and exocrine glands. So they're all made of epithelial cells. And what's the difference between an exo and an endo? One secretes
The
body surface, which is the exocrine.
Other one's in the blood.
Endocrine secretes hormones into the bloodstream. So exo is out, endo is in. So exo is coming out, like your sweat glands is an example of an exocrine gland. And then endocrine, we have a lot of examples. Okay. Let's see. L. What are the different types of connective tissues? The loose, the blood, tendon,
Bones.
and bones. Okay, so there's 4. Loose, L-O-O-S-E, loose connective tissue, tendon, blood, and bone. Where would loose connective tissue be? It'll be around in the interstitial area. Can you guys give an example of the loose? I don't think we went over like specific. Oh, so we let's see. Different types of connective tissue. And then what's next? M. Know the difference between an organ and an organ system. So if I give you the stomach, and we're going to study the renal system. Which one is the organ and which one is the organ system? Oh, because I said okay. 3A. What is homeostasis? So this is on your quiz. So it's a what? Is it a static or a dynamic event? It's a dynamic and what? Maintain a stable
State and internal environment.
state of internal, okay, environment. Now the word internal environment can be what? Can be, there's also other words that you can use that refer.
Intracellular fluid.
So internal, ECF is also another word that's associated with internal. And what's the other one? Plasma and interstitial fluid. So plasma and interstitial fluid are all extracellular fluid, which are your internal environment. That's on your quiz. Are we good? And therefore, what is internal environment? We just mentioned it. It's the extracellular fluid, which is composed of plasma and interstitial fluid. D, what is the percentage of total body water relative to the body weight? 60%. And E, the ratio between the fluid compartments, so your intracellular and your extracellular fluid, are they equal in terms of, ratio? No, which one is larger? ICF is larger, yeah, 2/3, and then, an ECF is smaller, okay. Oh, so D 60%, so do you want the numbers, or I'm just gonna say larger and smaller?
ECL's 1/3.
I'm sorry, ECF is 1/3, yes. Oh, letter E, we're on letter E, number 3E. It says, know the ratio between the fluid compartments relative to the total body water. So the ratio, so there are two compartments, your extracellular and your intracellular fluid. Your intracellular fluid is 2/3, and 1/3 would be your extracellular fluid. And then between the on the extracellular fluid, what's the ratio of your plasma to your interstitial fluid?
80-20.
80 to 20, yes. So 80 would be your interstitial fluid, and 20% would be your plasma. Letter F, know the types of extracellular fluid. I don't know if you wanted, we just kind of glanced through just need to know that there's the plasma, your interstitial fluid, there's many different kinds, but I'm not going to ask you the different kinds of interstitial fluid. But I will mention about intracellular fluid. We did say an example, your cytosol. So for letter F, just focus on the intracellular fluid, which is your cytosol. Your extracellular fluid, I'm not going to ask you different types of interstitial. Keep it simple. You guys already have so many things to, next page, what factors are homeostatically regulated? So far, the things that we've been studying, like temperature, body temperature is homeostatically regulated. What else? Which one? Okay, the hormones are homeostatically regulated, the protein. The concentration, your plasma osmolarity. So I'm just going to focus on the things that we've covered so far. So osmolarity, plasma osmolarity. We looked at tonicity. If there's a difference in osmolarity of your environment, it affects your cells. Anything else that we covered about homeostatic regulation besides temperature, plasma osmolarity? We'll go through the others, but those two, we'll just focus on those two. Letter H, the body compartments. Oh yeah. What is not at equilibrium? What is at equilibrium? Do you want to know this? Okay. What is at equilibrium? What is not at equilibrium? The electrochemical gradient of individual solutes. But what is equilibrium? It's the osmolarity of the fluid compartments are at equilibrium. Your ECF and your ICF have equal, same amount of concentration. But the components that make up each of these compartments have different concentration between their ICF and ECF. You guys okay? Number 4, define the following. So let me know if you want to skip any of these. You know the compositions of a solution? Yeah. Yes, a solute and a solvent. And then what is a solute? It's a substance that dissolves a solvent, that gets dissolved in a solvent. An example would be sodium chloride, glucose. Again, these are all Bio 100. What is a solvent? Substance that dissolves a solute. An example of that would be water, ethanol. Concentration, do we understand when we say what is the concentration? It's the amount of the solute for a given volume. always a measure of the solute, not the solvent. And the abbreviation, what is the abbreviation in unit for molarity? So the unit for molarity, abbreviation for molarity is capital M, and the unit is moles per liter. And then, what is the abbreviation? Oh, what is osmolarity? Do you guys know what an osmolarity is? So it's the total solute particle. Total solute particle concentration. Adding all of the dissociated and non-dissociated ions and solutes. And then the abbreviation for osmolarity is capital O, lowercase sm, and unit is osmol. So osmol represents the total solute particle. And then over a liter, over a volume. So this one here is just the amount of the solute, but this one here is telling you the total solute particle. Given, whether it's dissociated or non-dissociated. And then what is the osmolarity of the ICF and ECF? So again, they're at equilibrium, so it's 0.3, which can also be written as 300 milliosmoles. This is on your quiz. I only do this because you guys are here. Otherwise, if you don't notice, you have to read the sentences on the quiz. Otherwise, you won't catch it. And then number 9, are the concentrations of the fluid isoosmotic to each other? Yes, they are. So ICF has a 0.3 osmolarity and ECF has 0.3 osmolarity. However, the individual ions or solutes are not equal between the ICF and ECF. Number 10, know if the concentration of sodium and potassium ion are greater in ICF or in ECF. So sodium is greater where? Sodium is where? ECF, and then potassium is in ICF. So there's more sodium in the ECF than in the ICF, and then potassium is greater in ICF than in ECF. Number 11, so convert 1 molar of glucose into osmolarity. It would be 1, okay, osmolarity of glucose. And then the next one, 1 molar of sodium chloride is equals to 2. And you don't need a calculator. Okay. Number 5, are we good? We're good? Okay, number 5. So you can check which is which. Is it intrinsic or extrinsic? So number 1, intrinsic or local. So local, another word for intrinsic. Systemic is another word for extrinsic. So number 1, Marisa said it's local or intrinsic. Number 2, extrinsic or systemic. Number 3, intrinsic or local. And number 4, extrinsic or systemic. Okay, what clue, how do you know that this is intrinsic or extrinsic?
It's at the distance or when it's close.
Yeah, distance or when it's close or within the vicinity. Yeah. So if it's close, you don't need a nervous system or endocrine system. You don't need the neurons or the blood vessels to travel from point A to point B. But if it's distant, then that's the only way to get from point A to point B. Okay, good. Page 5, letter B. So match the following. So number 1, detects deviation is what?
Sensor.
It's a sensor, okay, or receptor. 2, body structure that produces response.
target site.
Okay, 3. Send along the afferent pathway to the integrating center.
Input signal.
Which type of signal?
Input.
Input, okay, and then number 4, output. Okay, how do you know which is which?
Is efferent is going away from the brain.
Okay, yeah, efferent is going away from the brain, going to the target cell. Afferent is going to the brain or integrating center. Okay, number 5, the change that occurs when the regulated variables move out of the desirable range. Stimulus, okay, and then 6 determines response.
Integrating center.
Yes, so the one that determines the response is your integrating center, which is your brain. We're good? Yes? Pretty simple so far. Alright, letter C, how does the control system operate? So know each of the characteristics. So negative feedback
Opposes the initial change.
opposes the initial from the initial change. Okay, so if the if I'm having a high blood pressure, if I want to respond by negative feedback, what would be my response? Low. Very good. If it's a positive, if I'm having a high blood pressure and I'm responding in a positive feedback, then what would be my response? It will continue to increase. Okay. So it reinforces the stimulus. And then feed forward would be something that I am, hi. Oh, you can borrow a laptop. Feed forward is something I'm anticipating. Anticipating for something that will happen. I'm already responding to something that will happen. So that's feed forward. Yes, what is your name? I'm gonna get to know everybody. Abby. Okay, hi Abby.
Is positive feedback like common?
Oh, okay, so now we're gonna go and says, in addition, identify which is widely uncommon. Okay, so widely would be negative. Okay, uncommon would be positive, and infrequent would be feed forward. Is there anything else that we need to know about negative, positive, and feed forward? So if I give you an example, you'll figure out what type of response. Yes? Pretty simple. Number 6A, where are the receptors and integrating centers involved in regulating body temperature in response to cold and heat? So if it's, so where are the receptors? The skin and in the brain, the hypothalamus. Okay. The skin receptor is also known as the peripheral thermoreceptors. Do you want me to write it? Okay. So the skin, so there's 2 receptors. The skin, which is aka the peripheral circumference thermoreceptors. So these are special structure that detects the changes, thermoreceptors. And then the other one is the hypothalamus, which is in the brain, and anything associated with the brain is called central. So the word central is always synonymous with the brain. So this is located in the brain, and it detects changes in temperature, thermoreceptors. And then the integrating center would be in the brain, which is specifically in the hypothalamus. Okay, so in the so all of these information from the skin or in the so the skin. This one here detects your core temperature, your internal temperature. So the main receptor is the core temperature, which is in the hypothalamus. And then all of these get feed into the hypothalamus. But if it's in the anterior, what kind of temperature is it responding to? The heat. And then if it's posterior, then it would be the cold. if the peripheral thermoreceptor is projecting that it's cold, then it would, the integrating center, the one that will determine what response will be, would be the posterior hypothalamus.